As of May 2024, the world finally broke away from the year-long spell of record-breaking temperatures. It was caused by the fifth strongest El Niño Southern Oscillation event in recorded history, resulting in widespread droughts, flooding, and other natural disasters across the globe. With El Niño finally subsiding, the focus shifts to the upcoming La Niña event. NOAA's Climate Prediction Center predicts a 71% risk of catastrophic La Niña in the remaining months of the year. But what's truly shocking is the forecast for 2025. In this video, we will take a look at our changing planet and what La Niña will do to Earth in the coming year.
Welcome to Why, where we ask the questions that unlock the secrets of the universe.
For as long as humans have existed, weather has captivated us. In ancient times, myths were born to explain its unpredictable nature, but now we understand that weather and climate are controlled by complex factors like Earth's orbit, axial tilt, atmospheric circulation, and the seasons. One of the most significant factors influencing our climate is the El Niño Southern Oscillation ENSO cycle, which includes El Niño and La Niña events. ENSO is a natural climate phenomenon that has been occurring for tens of thousands of years, with evidence suggesting it may have contributed to the catastrophic decline of ancient civilizations. The recent El Niño event, which finally came to an end a few months ago, was a powerful reminder of the devastating impact of ENSO. Record-high ocean surface temperatures, unprecedented heat stress on coral reefs, drought in the Amazon rainforest, and extreme rainfall with dangerous consequences for North America were just a few of the consequences. The event also triggered Zambia's worst drought in decades, fueled India's 20-day heat wave, and scorching heat waves in several parts of Central South America. Now, scientists are predicting the arrival of La Niña in late 2024 or early 2025. With that shift, the global climate will change again. But to begin, let's first establish some important context. Life on Earth is shaped by numerous cyclical patterns. We see this in the regular occurrence of day and night, the transitions between seasons, and the shifting tides. While these cycles are generally predictable, they can be influenced by fluctuations in climatic conditions. Periods of greater stability are referred to as ENSO neutral. However, every few years, fluctuations in wind and ocean surface temperatures can signal the onset of an El Niño or La Niña event, marking a shift from normal conditions. These events disrupt global atmospheric patterns and can lead to extreme weather and environmental damage. Here's a little thought experiment. Imagine being on the International Space Station, observing Earth from above. You would see the planet's spherical shape, and it's clear that sunlight affects the surface unevenly. More light and heat reach the equator, where sunlight strikes most directly, compared to the poles, where sunlight arrives at a lower angle. Similar to how hot air balloons rise or steam escapes from a boiling pot, warm air at the equator rises as it is heated by direct sunlight. As this warm air ascends, it cools and condenses into clouds, contributing to the lush tropical rainforests near the equator. The rising warm air pushes cooler air away from the equator toward the north and south, where it eventually sinks back down. This cool air then travels along the surface back to lower pressure near the equator, completing what is known as Hadley cell rotation. So, what's the link between this worldwide circulation of air and the El Niño La Niña phenomenon? Well, it turns out that the surface winds from Hadley cells get a little nudge toward the equator because of the Earth's rotation, thanks to something called the Coriolis effect. This effect is what forms the trade winds on either side of the equator, and alterations in these trade winds signal when we're approaching El Niño or La Niña events. Historically, these trade winds have been so predictable that sailors relied on them for navigation for centuries, hence their name. Traces of the ENSO, El Niño Southern Oscillation, stretch back tens of thousands of years in paleoclimate records like coral fossils, and we have documented ENSO in writing as early as the 1500s. You might be interested in knowing that the El Niño events might have helped Spain in their conquest of the Incan Empire in the 1500s and could have contributed to crop failures and unrest that sparked the French Revolution in the late 1700s. Despite ENSO's significant global impact on weather and ecosystems, it wasn't until the 20th century that we began to grasp the mechanisms driving it. The first major breakthrough came in the 1920s when British scientist Sir Gilbert Thomas Walker aimed to better understand monsoon strength in India. In his quest to predict these monsoons, he discovered the Southern Oscillation, a periodic shift in air pressure across the equatorial Pacific Ocean. This oscillation was part of a larger air circulation pattern that hadn't been identified before and was later named the Walker Circulation. To put it in perspective, imagine the Walker Circulation like Hadley cells, but instead of moving air north and south, it moves air east and west across the equatorial Pacific. Unlike Hadley cells, which are driven by sunlight, the Walker Circulation is influenced by the easterly trade winds and ocean temperatures. It took another 60 years for scientists to connect the shifts in air pressure over the Pacific with the fluctuating warm and cool water patterns in the region. Together, these form what we now recognize as the El Niño Southern Oscillation, or ENSO. El Niño refers to changes in sea surface temperatures, while the Southern Oscillation relates to simultaneous shifts in air pressure. Unlike Hadley cells, which consistently move air north and south, the equatorial Walker Circulation is less stable and can undergo dramatic shifts as part of the Southern Oscillation. Every few years, the Pacific Ocean surface temperatures and trade winds experience fluctuations, signaling a shift in the Walker Circulation. These shifts, known as El Niño or La Niña events, disrupt global weather patterns and can have far-reaching consequences for ecosystems across the planet. Hey guys, just a moment. Before we continue, be sure to subscribe our channel. Click on the bell. You will help us to make products of ever higher quality. Now, let's dive deeper. What happens to the Earth during catastrophic changes? In neutral ENSO phases, sea surface temperatures and trade winds are basically near-average conditions. These winds sweep across the Pacific, nudging warm surface waters from the coast of South America toward Australia and Asia. As the warm water heads west, colder, deeper waters bubble up to the surface. This phenomenon, known as upwelling, brings nutrient-rich cool water to the surface, supporting phytoplankton and in turn sustaining other marine life, including fish. When ENSO is neutral, global weather patterns tend to align with normal expectations. This means typical hurricane activity in the Atlantic and average monsoon rainfall in Southeast Asia. The Walker Circulation lifts warm, moist air above Southern Asia, Northern South America, and Central Africa, which explains why these regions house vast, thriving rainforests. The influence of this equatorial airflow is significant, so it's easy to see how even small changes in the system can trigger widespread effects on global climates. How can we tell when El Niño is on the way? What were the effects of the recent El Niño event? The first signs of an El Niño event are weakening trade winds and rising sea surface temperatures in the Pacific, as seen in 2023 and 2024. During El Niño, the massive columns of warm air over rainforests shift, disrupting Asia's monsoon season and leading to droughts and water shortages affecting billions. The last event brought 9 atmospheric rivers to the western U.S., causing transportation chaos, landslides, and floods. Atmospheric rivers are like streams of moisture in the sky, releasing heavy rain upon reaching land. El Niño reverses normal weather patterns, causing droughts in rainy regions and heavy rain in typically dry areas. The 2023 El Niño event caused a ripple effect in global shipping, leading to delays as the Panama Canal struggled with low water levels due to lack of rainfall. El Niño, the warm phase of the ENSO cycle, brings higher than average Pacific sea surface temperatures, disrupting global weather patterns and ecosystems. Coral reefs, for instance, rely on specific sea surface temperatures to thrive, supporting an incredible array of life on Earth. But when temperatures rise, corals expel their algae, leaving them drained of color and vulnerable. The 2023 to 2024 El Niño event was particularly devastating, with a record 99.7% of Atlantic tropical reefs experiencing bleaching level heat stress. The warmer Pacific waters and weaker trade winds also slowed or stopped the upwelling of nutrient-rich water, leading to a dire situation where phytoplankton declines, forcing fish to migrate or perish. This has a ripple effect across the food chain, impacting other animals and coastal communities that rely on fish for nourishment or income. Now, we've looked at what happens during neutral ENSO periods and the devastation of El Niño between 2023 and 2024. Now, what should we expect with La Niña approaching? Although El Niño gets more attention, La Niña is just as powerful. This extreme weather event is characterized by stronger than usual trade winds and cooler than average Pacific sea surface temperatures. Think of La Niña as a turbocharged version of neutral conditions, but with some interesting twists. For most parts of the world, La Niña amplifies the typical neutral conditions, but with some notable exceptions. The columns of rising warm air above South Asia and eastern North America become even more pronounced, while the warm air above Africa does a surprising reversal. Just like El Niño, your experience of La Niña depends on where you are in the world. As of August 2024, the U.S. National Oceanic and Atmospheric Administration is predicting a 66% chance that La Niña will develop between September and November 2024, with a 74% chance it'll continue until winter 2025 to 2026. Current models suggest a 50% chance that this La Niña event will peak at a moderate strength, but don't be surprised if those predictions change from month to month. Here's the thing. A strong El Niño ending in 2024 doesn't necessarily mean the upcoming La Niña will be equally extreme. Sometimes a strong El Niño paves the way for a strong La Niña, but other times it's followed by a weak La Niña. With only 10 instances in recorded history where the ENSO, El Niño Southern Oscillation, has switched from El Niño to La Niña within a year, there just isn't enough data to make any solid predictions. It is important to note that the strength of an ENSO event doesn't always translate to its impact, so scientists are urging us to stay vigilant and prepared for whatever La Niña brings. So, what happens when La Niña takes hold of winter weather across North America? Well, it's a bit of a mixed bag, to be honest. The northern part of the continent can expect a colder and wetter winter, while the southern part is likely to have a warmer and drier winter. Additionally, La Niña increases the likelihood of a more active hurricane season in the Atlantic, with the potential for more and stronger hurricanes. In East Asia and Australia, La Niña typically brings significant rainfall, while in Africa, it can lead to wetter conditions in western areas and drought in eastern regions. But what about Europe? La Niña's impact here is a bit more nuanced. While the connection between the two isn't as clear-cut as we'd like, it's expected to bring lower than average temperatures to Central and Western Europe, with less precipitation across the mainland and more in the north and south. Here's the thing, though. When it comes to La Niña predictions, there's a bigger picture to consider: the impact of global warming on the El Niño Southern Oscillation (ENSO) cycle. While ENSO has been occurring for millennia, it's unclear how climate change will affect this cycle. Despite short-term temperature swings from ENSO, the overall trend of global warming continues to rise. This means we're entering uncharted territory, where severe weather events are likely to escalate. Take a look at recent history, and you'll see that El Niño and La Niña events have become stronger and more frequent, leading to more droughts, floods, heat waves, wildfires, and severe storms. Climate change is likely to amplify the ENSO cycle, but exactly how is unclear. As the planet continues to warm, it's essential to understand the complex and unpredictable nature of ENSO to better prepare for the increasing severity of weather events. Here's where we call it a wrap. What do you think about the coming La Niña? What would you like us to cover in the next video? Feel free to leave your answers in the comments below. If you like this video, then you should check out the one on your screen. This video on recent unusual activities in the San Andreas Fault will blow your mind. Thank you for watching.